Hello and welcome to the IFT460 final project presentation for Arizona State University fall semester. My name is Jason Merritt and I will be demoing to you my final project for class. For this project, I chose to do the weathering monitoring system to create a full end-to-end level 3 IoT architecture that was capable of collecting sensor data, transmitting it to the cloud, processing that data in a database, and then visualizing the data in two ways. One being the email requirements for the project, and a second was a visual dashboard I created. So this project is a system that is both remotely configurable and it sends data to the cloud and stores it. For this project, I leveraged a Raspberry Pi for the edge device, and it is down here on my desk. You can't see it out of camera, so I'll just pull up a picture. You can kind of see how we've got it set up. Here we've got the Raspberry Pi, and then I've got my breadboard. I used the DHT11 sensor that was included in the kit for this class. I chose the sensor because it does temperature and humidity readings, and it was pretty easy to configure once it was all set up correctly. I ended up plugging this sensor into GPIO pin 4. This will just read the temperature of the room I'm sitting in and continually report that data. So to get that data reported, I captured it and send it in JSON messages to AWS IoT Core, and we're going to hop into that and actually demo it live here in a second. But the simplest part of it is there's a Python script running on the device, and we'll talk about that. First thing when I mentioned the script is I could have probably improved having it start up when I booted the Pi by giving, I think it's system D privileges. But right now I'm just going into the Pi myself and then starting the script, but that does not start my system up exactly. So let me go ahead and get that set up. So here on my screen is my remote terminal to my Raspberry Pi. And you can see I'm in a virtual environment where I've got all of my scripts loaded and everything, all modules that I need to make this run. So let's go ahead and start the weather app. So you can see here it outputs a couple things about MQTT, what command topic it subscribes to, and we will use those command topics in a second. So you can see it's outputting waiting for start command. This is one of the things I looked at to do for the project to show that I can configure it remotely. So let's go ahead and do that. So now here with AWS, we've got a couple different services used, and we'll talk about them all. But first is AWS IoT Core is how my device is connected to it. It is connected through a device certificate to do secure communication. And we will go ahead and send our first command so we can watch our data come through. So if I do action start in this payload and I publish it to the Pi, we'll see the command publish. And we can actually come back to the Pi and now see it's received the command start, and it's going to start publishing temperature data. And this temperature data, right now, we're in Celsius. It's publishing temperature, humidity, and a timestamp. So then I've got a couple other outputs here. You'll see SMTP is doing the email. And that's really all this is going to show you on this screen. The rest of it we can manipulate and view in the AWS console, and we'll talk about that. But before we go too far, I want to demonstrate all of my commands. So we'll actually stop the device. We'll do a stop. And we'll see now we're back to a waiting state is what I'll call it to start again. So before we do the start, let me grab my other command that we made. And we will do Fahrenheit. We'll configure the device. So now, set unit. Now we're in Fahrenheit. So when I start it again, we're going to report Fahrenheit instead of Celsius. So let's do a start. All right, so we've started again. We can see the units have changed from Celsius up here. We're now reporting in Fahrenheit. So we'll let that run for a little bit, and we'll talk about everything else in AWS. Not much more to say about the IoT services. That's pretty much all of it. The hardest part about this was, okay, what do I do with this data now that I have sensor readings coming into AWS? And I elected to use AWS DynamoDB to store this data. But before I could store it, I needed a way to get it there. So I ended up using message routing and created a rule that would trigger a Lambda function. So we'll talk about the first Lambda function. And I won't go over these in detail, but I think these are worth mentioning. So this one right here is going to grab all of my data from IoT and send it over into my DynamoDB. And you can see I've got a whole Lambda function written. It works just fine. It's more easy to show this in the DynamoDB to see what it does. But the important part is here, I struggled and I had to figure out exactly how to name my table to get it to go into the correct DynamoDB. The second function will come in a little later, but this function is getting the information from Dynamo and getting it to my API gateway for the weather dashboard that I'll demonstrate later. So let's look at DynamoDB. So here we have a table. It's called EHT11. That's my sensor name. But if I explore the items in the sensor, we can see I've got temperature, humidity, temperature unit, and the timestamp coming in. And those timestamps are changing. So now what do we do with all this information? We can actually, for one, send the email. As you can see here, I've got 13. And I believe I have this set sending every 5 seconds right now, which is a lot, but just for demonstration purposes, I'm continually getting emails. Here's the 14th email with the same information: timestamp, temperature, and humidity. From that SMTP user that I configured in my script, it's sending it to my personal Gmail. Now, the other thing we haven't talked about is the API gateway. In Amazon, I set up an API gateway that does a RESTful GET to pull the data from the database excuse me, through the / readings. Through that route right there, it'll pull the data. The biggest trouble I had with this was getting cores set up correctly. And I don't think I ever got it set up fully correctly because I actually had to set up a virtual web server on my client to access my my dashboard. And that's pretty simple. So I'm just using Python and starting up a little web server. But if you look at the raw data coming in, this is my API. And you can sit here and watch the data come in and you'll refresh and it'll add more every 5 seconds. But this is not very conducive to read. So I ended up making a dashboard that pulls in all of this data. And you can see here, it's got historical by timestamp, current data, and this big jump is where we switched the Celsius to Fahrenheit. That kind of throws it up for a loop. And this is live data, so if you refresh, it will continue to refresh and add more information. But holistically, that is the project. I believe this satisfies all requirements for the final, and the fact that it is a full level 3 IoT architecture. It is configurable from a remote controller via MQTT test client. I have an API set up that's doing RESTful queries, and the Raspberry Pi is sitting here with me, and I'm reporting data into the cloud. With that demonstration, I'd like to thank you for your time.